We're ready to get started with Unit 7, and Unit 7 involves a lot of geometry. And the first thing that we're going to talk about is the Triangle Sum Theorem, S-U-M. So the I can statement here is I can solve problems using the Triangle Sum Theorem. And you actually learned the Triangle Sum Theorem and along with some other vocabulary words that I'm going to remind you of today. So let's take a look at the warm-up here. It says, what is a triangle? Remember, a triangle is just a three-sided polygon. So I can draw a triangle that looks something like this, kind of a classic shape. We could draw it really long and drawn out, kind of like that. We could draw it really tall and skinny. Anything like that, totally okay. That's a triangle. Tri means three, so it's got three angles, three sides. Everybody knows what a triangle is. Next question, maybe not so easy. What's a theorem? What is a theorem? Well, a theorem, to put it really simply, is just this. It's an idea that has been proven true. And when we prove a theorem, we normally take things that we already know to be true and we kind of build them up and combine them together to make some other idea that we've come up with and make sure that that's true. So it's an idea that has been proven true. And a sum is an addition problem. Addition problem. Sometimes we say that a sum is the answer to an addition problem, and that's fine as long as you know that the sum involves something dealing with addition. Okay, when we're working with geometry, we need to make sure that we understand the notation and the vocabulary. There's a whole bunch of vocabulary that goes along with geometry. So we want to make sure that we know the notation and the vocab. We'll usually name points using capital letters. Capital letters. And let's just review really quickly. If we're talking about a point, so if I had this point right, P, if I wanted to give it a name, I'm going to give it a capital letter for a name. So a lot of times we'll say like this is point P. If we've got more than one point, if we've got 2 points, then we can make some other shapes. So 2 points can define, this is a line right here. So we would say line AB, that's a line, it extends forever in both directions. This one right here, because it starts at A and goes past B and continues in that direction, that's called a ray. So we would say ray AB. And this right here, it's got an end point on each one. So it's not a line, it is a line segment. It's one piece of a line. It stops. So that's segment AB. Whoops, segment AB. Make that look right. So 1 point, 2 points can define a line, a ray, or a segment. 3 points can define an angle. So let's write angle right here. And I've got an asterisk by this because when we talk about an angle, we are normally talking about this angled space right in here, what this measurement is. And we'll talk about how we measure these in just a second. So normally the angle would be this inside one. If we were talking about this outer angle, this big angle outside here, we'd have to indicate that another way. So normally when we say angle, we're talking about that little angle on the inside. And to make things consistent, we need a standard way to talk about the measure of an angle. So if we're talking about this angle right here, the symbol that we use, rather than saying the word angle every time, is we use this little angle sign right there. Now, it's not like a less than. Notice that the bottom part of that is kind of horizontal. So it looks like this. That's an angle sign. So if we were talking about this particular angle over here, we could say that that is angle CAB. So C to A to B. Notice the vertex is in the center. Or we could say angle BAC. So B, then A, then C. Again, the vertex is in the middle. A lot of times if we've got something like this where there's only one point or one angle that could possibly be associated with the vertex, then we just say angle A. So if we can get away with fewer letters, we will. I do want to show you something that you cannot do, and I'm going to change colors for this. We could not do this, not angle A, B, C. That would not work. And the reason this wouldn't work is because the vertex is always in the center. So we would go in this order, A to B to C. We'd be talking about that angle right there, and that's not the one that's indicated in this diagram. So please make sure you're aware of that. I've already used this word a couple of times. The corner of an angle is called the vertex. The vertex is a fancy word for the corner of a figure, corner of an angle. And then one of the most common ways to measure angles is using degrees. And you're probably familiar with this. There's a little symbol like this. It's a little open circle. It's written superscript up above like this. And let's take a look at a couple of examples right here after we talk about some names that we can give these. So it says an acute angle is an angle that measures less than, you probably already know this, acute is less than 90 degrees. Notice how I write a big 90 and then an open circle up above there for the degree sign. A right angle measures exactly 90 degrees. An obtuse angle is an angle that measures more than 90 degrees. And a straight angle, hopefully you know what a straight angle is. A straight angle is an angle that makes a straight line, so it does like this. So it'd be kind of like we have C right here, A right here, and B right here. That angle would measure 180 degrees, because what we're doing is we're kind of putting two 90-degree angles together like this. And this is something you shouldn't forget. There's 180 degrees on one side of a straight line. That's going to come up again and again and again. Common property that's used in geometry. So let's take a look down here and let's measure these. So this, let me mention that now. As a reminder, when we have this script M that's written in front of the angle symbol, we read this. This is the measure of angle A. So if you see the M, it stands for measure, the measure of angle A. So the measure of angle A is 20 degrees. The measure of angle B is 127 degrees. And the measure of angle C, this isn't indicated here, but like I reviewed over here, that little box is the mark of a square. And squares have four 90-degree angles. So that is a 90-degree angle in there. So we're going to put 90 degrees right here. This one would be a right angle. There's an example of a right angle. This is an example of an obtuse angle. And this is an example of an acute angle. Okay? Now, along with the basic ideas above, there are also a couple of important things from 7th grade that we need to be reminded of. These are not things that we can forget, so we've got to make sure that we've got these straight. These two ideas are very, very important because they're used all the time. Now, along with this one right here, that there's 180 degrees on one side of a straight line, let's see if you remember these. How many degrees are there on the inside of a triangle? How many degrees are there on the inside of a triangle? Well, there are 180 degrees. I'll give you a little argument for that in just a second. And then the other one is, what are vertical angles and what special property do they have? What are vertical angles and what special property do they have? So I'm going to draw a picture of some vertical angles. That might be a reminder. And then I'm going to come down here and fill in two of these boxes right here that talk about the Triangle Sum Theorem and vertical angles. So the sum of the measures of the interior, if we want to be really specific, interior angles of a triangle is 180. That's the fancy way to say the Triangle Sum Theorem. The sum of the measures of the interior angles on a triangle is 180 degrees. We could say it really quickly. How many degrees are there on the inside of a triangle? 180 degrees. Okay. Now, do you remember why this is the case? It has to do with how many degrees there are on one side of a straight line. Now, there are lots of nerds on the internet. I found a pretty quick video that'll remind us of what we did in 7th grade to kind of show and demonstrate how the Triangle Sum Theorem comes about, why there are 180 degrees in a triangle, and I'm going to show you that right now.
Why, hello there. My name is Mr. Triangle, and here's my friend, Mrs. Trapezoid. Hi, everybody. My friend is Mr. Rectangle. Why, hello there. My name is Mr. Rectangle. My angles on the inside equal 360 degrees. What about yours, Mrs. Trapezoid? Well, my angles equal 360 degrees. By golly. What are yours, Mr. Triangle? Well, my angles equal, well, I don't know what my angles equal. Bloop, 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 bloop. No! What am I gonna do? Let's figure it out, huh? Yeah?
You got a friend in me. You got trouble, and I got them too. There isn't anything I wouldn't do for you. If we stick together, see it through, 'cause you...
Wowza! We learned that your angles are a straight line, which makes 180 degrees. Oh my gosh, that happens every single time with a triangle. I can't believe it. What do you think, Mr. Triangle? Well, it kind of hurt. Well, I'll be okay, but it's awesome to know my angles always add up to 180 degrees. Man, it just made my school year. I can't believe it. I'm just awesome.
pretty crazy video, right? So basically, here's what it comes down to. If we've got a triangle, no matter what shape it is, and we've got angle A, and we've got angle B, and we've got angle C, if we tear those off and we put those together, so if we tear them off and we've got angle A, and we tear angle B off and put it right here, and then over here we've got angle C, they will always make a straight line. It happens that way every single time. So again, this idea that on one side of a straight line there's 180 degrees, that comes back to help us here. Now, I am going to show you in a couple of sections from now, I am going to show you a little bit more of a rigorous proof of why that actually works the way it does. It doesn't have anything to do with tearing paper or anything like that, but that was the basic idea. So hopefully you remember the Triangle Sum Theorem. We're going to be using that. And the second thing that we want to remember is vertical angles are blank angles formed by intersecting lines. They are opposite angles formed by intersecting lines. Opposite angles formed by intersecting lines. Vertical angles are always congruent. Congruent. Okay? And congruent is the geometry word for equal. Now, what would be really impressive is, do you remember what the symbol is for congruent? If we say two things are congruent, what we mean is they're exactly the same size and shape, so they're exactly the same size angle and that sort of thing. Well, the symbol for congruent is this. It's an equal sign with a little squiggly on top of it. So I'm going to put that right there. And then a question here, do you remember why this is the case? And the hint for this is the same as above. So let me give a numeric argument for this one right here. Let's say that this right here is 50 degrees. If that's 50 degrees and I were to cover up the bottom half of this line, so I just cover it up down here, there's 180 degrees on this side of the straight line. So if there's 180 degrees on the top side of the straight line, this has to make up the difference. So I'm going to do 180 minus 50. We end up with 130. So there's 130 degrees over there. So this is 50. That's got to be 130 because this is a straight line. But I can do exactly the same thing here. I can ignore the left-hand side of this line, and I can make the same argument. If this is a straight line, there's 180 degrees over on this side of that straight line. If 50 of them are here, we could do the same little subtraction problem and figure out what it is right here. So this is going to be 130 degrees, okay? And then by the same token, I'm going to cover up the top part of this, and we're going to say, well, look, if this is a straight line and there's 130 degrees here, we've got to have 180 degrees altogether. So this one on the other side, this missing angle here, has to be 50 degrees. Okay, so the ones that are vertical angles are this angle right here and this angle right here. They are opposite from each other and they're congruent to each other. And this one right here and this one right here, I'll use little symbols to kind of indicate. So the two that are across from each other, opposite in the intersection, when two lines intersect, those are vertical angles and they're congruent. These are vertical angles and they're congruent. So I'm going to flip over to the other side, and let's use that information, the Triangle Sum Theorem and vertical angles, and let's see if we can figure out some problems. This one says find the missing angle. So you'll notice that we've got 80 degrees right here, 35 degrees right here, and we're missing that angle there. Well, there's 180 degrees on the inside of a triangle, so one way that we could do this is we could say, look, I've got 80 degrees, I've got 35 degrees, and I don't know what this one is right here. I'm going to use an X to represent it. But I do know that I have 180 degrees altogether. So we're going to add all three of these up and set them equal to 180 and then solve. So we're going to get rid of this by subtracting 80 and subtracting 35 from both sides. So we get X equals, we'll do 180 minus 80, that's going to be 100, and 100 minus 35, that's going to be 65 degrees. If you want to double check me on your calculator, you're welcome to. So this is going to be 65 degrees right here. Now we can write an equation for this, which I recommend that you be able to do, or you can just say, look, I'm going to take 180 degrees and I'm going to subtract off the pieces that I already know that I have. So again, this would subtract to be 100, and then 100 minus 35 ends up being 65. There's the answer. Either way is fine. Being able to write an equation is a really good skill. There are going to be problems on the assignment and on the test and the practice test and stuff like that. Maybe a quiz where you do need to write an equation so we can kind of see what you're thinking. Okay, let's take a look at the next one. I'm going to change colors for that. I'm going to use an X for this. So we're going to have X plus 40 plus 90 equals 180. Again, we know this is 90 because of that right angle right there. So this is really x plus 130 equals 180. So we're going to subtract 130 from both sides, and we get x is equal to 50. So this is 50 degrees right here. That missing angle is 50 degrees, and I am going to put a degree sign on there. And then we've got this last one right here, so we'll take a quick look here. Let's see, I'm going to do this the other way. I'm going to take 180, change colors here. I'm going to take 180 and I'm going to subtract what I know I've already used. If we add those together, 127 plus 20 is 147. So we're going to go ahead and subtract here. Let's see, I'd need to borrow, so that's a 10, so that's a 3, that's a 3, so 33 degrees. So this missing one is 33 degrees. Okay, so we'll circle that. So that's an example of using the triangle sum theorem. All right, and then the next one says, can a triangle really have the following measurements, why or why not? So this one's 29 and 108 and 32. So let's take a look at this. It's drawn like a triangle, but it's got these measurements in here. And it's got measurements of 108, 29, and 32. So let's see what happens if we add these together. If I take 108 and I add 32, and then I add 29, let's see what I get. If we get 180, if 180, then yes. If it's not 180, then the answer is no. So if not, then the answer would be no. So let's take a look here. This would be 10 plus 9. That's going to be 19, carry the 1. Now wait just a minute. The fact that this ends in a 9, there's no way this is going to work, but I'll go ahead and finish this out. This is going to be a 6. This is going to end up being 169. There's no way that works out. So the answer on this one is no, and the reason is they don't add up to 180. So we'd say angles don't add to 180 degrees. Okay? Perfectly good work and reasoning. We've answered the question and given some justification. So we said the answer, and it says why or why not, and we gave our reason there. Okay, next one, it says find the value of x and find the measure of angle A. Now you'll notice that we've got a bit more complicated expression right here. We've got 70 here, 55 here, and then 59 plus x right there. It says find the value of x and find the measure of angle A. So this is where we're going to use the triangle sum theorem, because there's 180 degrees altogether, and we do have to write an equation because we're going to solve for x. So this is going to be 70 plus 55 plus 59 plus x equals 180 degrees. So again, take a look through here. I've taken one angle, two angle, three angles, all three angles, added those together and set them equal to 180. Now once I get to this point, this is no longer a geometry problem. This is now an algebra problem. So we're going to go ahead and add those together. So I pulled up the calculator, I added them together, and I got 184. We'll just double check and see that I typed the correct numbers in here, so I got 184. So 184 plus x equals 180. Now don't look at this and panic and say, wait a minute, we've already got 184 and we're only supposed to have 180. Remember, this is an equation. All we need to do is find a number that makes the equation true. So let's go ahead and do that. We're going to subtract the 184 from both sides. Certainly don't need a calculator to do that. We get -4. This is the answer. The answer to the x question is x is -4. Then it says find the measure of angle A. So if we look at the measure of angle A right here, I would actually have to plug this in here. So the measure of angle A is going to be 59 plus, we're going to substitute here, so I'll throw that in parentheses, 59 minus 4, so the measure of angle A is supposed to be 55 degrees. So I'm going to go ahead and circle that. There's all the work that went into this. So if this is 55 degrees, so I'm going to go ahead and cross that off. I'm going to write 55 degrees right here. 55 plus 55 would be 110, and 110 plus 70 would equal, you guessed it, it equals 180. So we know we got the answer right. So let's take a look at this next one here. Again, we're going to use the triangle sum theorem. We're going to add all of those together. So I'm going to do 3x plus 10 plus 6x plus 4 plus 76 equals 180. So I'm going to put these together and we get, let's see, this is 9x. These two together, 4 plus 76 would be 80. 80 plus 10 would be 90. Okay, and that actually turns out to be pretty nice because when I move this to the other side, these are numbers I probably don't even need a calculator for. This would be 180 minus 90 is 90. We're going to divide by 9, so we're going to end up with x equals 10. So there's one part of the answer. Remember, we need the value of x. So we've shown all this work, and now we're to the easy part. Once we know what x is, now we can find out what the measure of angle A is. Angle A is this one right here. So the measure of angle A is equal to 3x plus 10. So this is going to be 3 times 10 plus 10. So that's going to be 30 plus 10. So the measure of angle A is equal to 40 degrees. So I'm going to go ahead and circle that. Let's see, if this is 40 degrees, we could just double check here. Let's plug a 10 in here. If we plugged a 10 in here, this would be 60 plus 4. This would be 64 degrees. And do you want to check and see what 40 plus 64 plus 76 is? These would add up to 104, and 104 plus 76 would be 180. So we got that one right as well. Okay, all right. Now, let's take a look at these last couple. And I do want to emphasize this. So I want you to put a star by this, and I want you to keep this in mind. There are some people that really love geometry, and there are some people that do not enjoy geometry. They have a hard time visualizing what's going on. They're wondering when they'd ever see figures like this. But these are really useful. One of the most useful things about geometry is it teaches your brain how to string together concepts you already know are true to reach true conclusions about new problems you encounter. And we do this all the time in life. I mean, life is like one big story problem. We have to take what we already know and then we have to apply it in whatever situation. And geometry and math as a whole branch of study is something that teaches your brain how to take what you already know is true and then use that to solve some new problems. So we're going to take a look at the two of these, and don't be surprised if you see some problems like this on the test, because this really is the value. Can you take what you already know, put it together, and use it in some new way? So it says find the missing angle. So the missing angle is right here. I'm going to put a dotted circle around that. Okay, that's the one that we're missing. Now, if we knew what this angle right here was, it would be just like the ones up above. I know I could add these three angles together. They'd have to equal 180, and then I'm all set to go. But I don't have this angle. So let's look around at this triangle and see if we can find some other stuff that we can use. I've got a 30-degree angle here, and I've got a 55-degree angle there. And this is a triangle. That right there is a triangle. Well, we know that there's 180 degrees in a triangle, and if I add these guys together, 30 and 55, if I were to subtract those, that's 180 minus 85. Well, that means this is going to be 95 degrees. Now, that's not what the question was asking for, but that does get me a little bit closer, because if you'll remember earlier, and this is something we need to remember from 7th grade, this line right here intersects with this line right here. Now, if you wanted to ignore everything else on this problem, and I'm going to go ahead and cross everything else off for just a second. I know you can still see them, but just pretend. Let's focus in on this right here. This is like that diagram that I wrote earlier, where we've got two intersecting lines, and the ones that are across from each other, these two are vertical angles. So this one and this one are vertical angles, and this one and this one are vertical angles. And vertical angles are congruent. So what that means is, if I know this one's 95, I automatically know that this one's got to be 95 degrees. Now I'm going to come back here and take a look. We can ignore this stuff up here. We don't need that, but we do need this angle right here, because now I can do another triangle sum problem, and I can say, look, if I want to find what that is, I can take 180 and I can subtract 95 and I can subtract 21, and that's going to give me what the answer is. So I'll pull up the calculator, type those in, and we're all set to go. So I threw that in the calculator. I got the 180 minus 95 minus 21. I got 64. So the answer on this is 64. So that missing angle right there, this angle that they wanted us to find, is 64 degrees. So I'm going to circle that, and we are all set to go. Great example of we wanted to find something in this triangle, but in order to do that, I needed to string together a few things that I know about this triangle to be true, few things I know about vertical angles to be true, and we're all set for the next one. This is actually problem number 20 from your assignment, so make sure you pay attention to this one. We want this angle right over here. That's the one that we want. Same situation. We've got one of the angles, but we don't have the other one. So if I had these two angles, I can just do a triangle sum problem, do a little subtraction, and I can find that one. So I look over here. Well, maybe that 55 helps me. Maybe it doesn't. But if I look at just this first triangle in the diagram, so let me erase this other stuff here, or at least cover it up so we can't see it quite as well. And let's just look at this triangle right here. If I were to add those together and then subtract from 180, that will tell me what I have right there. So if I add 34 plus 56, that's a 0 and one more, so we end up with 90. So that's 90 degrees. So 180 minus 90, that's going to be 90. So this is a 90-degree angle right here. Okay, now how does that help me? I don't have any vertical angles like I did here. I can't say, well, because this one is 90, that one's 90, but I can do this. Remember, on one side of a straight line, there's always 180 degrees. So if I were to take this angle right here, this angle right here, and this 90-degree angle right here, add them all together, I'd have 180 degrees. So let's go ahead and do that. I'd have 90 plus 55 plus x equals 180. Or I could do that same thing that I did up above. I'm going to take 180 and I'm going to subtract what I get when I add those together. 90 plus 55 is 145. So if I do the subtraction, I end up with 35. So this angle right here is 35 degrees. Now, if you are not sure at all, we could grab the calculator really quickly and we could add those together. Let's just double check and make sure. I mean, say this was a test question. This all balances on the idea that this angle right here, this 90-degree angle, plus the 55 plus the 35 equals 180 degrees. So 55 plus 35, and we end up with 180. Okay, so we got that right. Now the last thing we need to do is let's use that triangle sum theorem. I know I've used 80 degrees. Gosh, that gives me 100. That's easy. And then I'm going to subtract 35. Subtract 35, and I end up with 65 degrees. So this angle over here is 65 degrees, and we can circle that, and we're done. All right. Again, the value of geometry is it teaches your brain how to string together things that you know are true and then to make conclusions about new problems that you haven't seen before. Really good skill. If you know how to do this stuff on the notes, then you should be in pretty good shape for the assignment. Good luck.